Okay, so in chapter 6, okay, we're going to learn what? Factoring. Okay, the entire chapter 6 is about factoring. Okay, the first section 6.1, it is about factor by grouping. Okay, yeah, factor by grouping, this is the last objective in this section 6.1 we're going to do. Okay, before that we are going to learn how to find the greatest common factor. Okay, greatest common factor, we usually use GCF for short. So later, when I mention, what is a GCF? Greatest common factor. Okay, so we will find GCF for what? A list of numbers. Also, we need to know how to find a GCF for what? A list of variable terms. And then we should be able to factor out the GCF. And then eventually we look at factor by grouping. Okay, so let's look at these objectives one by one. The first objective is to find GCF in the list of numbers. Okay, in the list of numbers. Guys, how do you understand greatest common factor? Say for example, we have a list of numbers. Say for example, this question A, there are two numbers. How do you find the greatest common factor between these two numbers? Greatest common factor must be a number which is a factor of all of this list of the number, right? Because it's a common factor, right? Common factor. And it is the greatest common factor means what? It is the largest number that it is what? Also the factor for every single given number. Okay, so GCF, the idea for GCF is the largest number that this number is also a factor for all of the given number, right? Now let's try to find, okay, what is the GCF for number 15 and 27? How to do it? What do we do? First, we are going to write each number as a product of prime numbers. Okay, so factor each number by as a product of prime numbers. How do we understand prime numbers? What numbers are prime numbers? 2, 3, 5, 7, 11, 13, 17, 19, and so on. Prime number is a number that can only be factored by 1 times by itself. Right? So that's prime number.
Like 11.
Yeah, 11. 11 can only be factored by 1 times 11. There's no 2 times something equals 11, right? Yeah, so prime number means this number can only be factored by 1 times by itself. Okay, how about number 6? Is number 6 a prime number?
No.
No. Why? Because 6 can be factored by 2 times 3, right? 2, yeah. It's not just 1 and itself, right? So now you know the prime numbers. So first, write each given number by a product of a prime numbers. Then determine what is the greatest common factor of the group of numbers. Okay, so let's try this question A together. Okay, so first we're going to factor 15 as a product of prime numbers. What is the first prime number we can try to factor 15? Can we try 2 times by anything equals 15? Yes or no?
No.
So how about 3?
Yeah.
Yes. So we can factor 15 to be 3 times by what? 5. Both number 3 and number 5, they're prime numbers, right? So, we say we can only factor 15 by 3 times by 5, right? How can we factor 27? 27 can be factored by 3 times by what? 9. And then 9 can be factored by what? 3 times 3. Okay? So 3 times 3 times 3, these are the factors for 9. So we can rewrite 15 as what? 3 times by 5, and then 27 by what? 3 times 3 times by what? 3. You guys, let's go. Now the thing is, what will be the greatest common factor? What is the GCF?
3.
Why 3? Because the 3 shows up in both. This 3 shows as a factor for both of number 15 and 27, right? Only 3. You may say, how about this 5? And see, 5 shows up as a factor of 15. But 5 is not a factor of 27. How about these 3's? They are the factors for 27, but they are not the factors for what? 15, okay? So GCF is what? 3. You guys? Do you want to try another question? The question B, I will leave it for yourself, okay? Let's try a list of numbers with 3 numbers, okay? So I would say, how about let's do question C. Find the GCF for 25, 125, and 200. At first, what should we do? Factor each number by prime number. So 25 can be factored by what?
5.
5. Okay. And 125 can be factored by what? 5 times by?
5 times by, actually,
Use a calculator. 125 divided by 5.
25.
25. So can we keep on factoring 25?
Yeah.
5 by 5, right? And then for 200, see? Everybody has a common factor 5, alright, from the 125. How about we factor 200 to be 5 times by something?
40.
40. And 40 can be factored by, see this?
5 and 4.
5 by what?
Oh, 8.
8, yes. And actually 8 can be factored by what?
2 and 4.
2 by 4, right? And 4 can be factored by what? 2 by 2, right? So, 25 can be written by 5 times 5. 125 can be written by C5, right? 5, 5, 5, right? And then 200 can be written by what? 5 times 5 times 2 times 2 times 2. Now, what will be the GCF?
5.
GCF will be 5 times what? 5, which is what?
Present in all of them.
25. So we have to make sure this 5 has to show, it's a common factor for all of the numbers. This 5 also common to every what number. This 5 is only a factor of 125, but it's not a factor of, it's not a common factor of 25 and 200. These 3 twos, they're not, right? So what will be the GCF?
25.
Yes, or we can highlight, right, like this, right? So GCF equals 5 times 5, which is what? 25. You guys feels good for a list of numbers? How about if we have a list of terms? Sixth example, let's look at question F. What is the greatest common factor of this list of terms? So this list of terms has what? A coefficient, which is a number, right? In front of it. Also, it has what? Variables with exponent, right? So, to find GCF, we are going to find a GCF of what? This list of numbers, right? Also, for these exponential expressions, are we choosing R square as the common factor for R square, R fourth power, R fifth, or are we going to find R to the fifth as a common factor?
R to the 5th has a common factor?
See? Okay, let's find a GCF for the number at the first, okay? So 28 can be factored to be
3 and 8. No, wait.
2 times 14, right?
Yeah.
2 times 7. So 2 to 7. 14 can be factored to be what?
2 and 7.
49 can be factored by 7 times what? 7, right? So what is a GCF?
7.
Why there's no 2? Because there's no factor 2 in the, for 49, right? So 2, there's no 2, so we cannot choose these 2. However, see, 17 shows up for all of what? The 3 numbers. Okay, so I would say I'm going to choose 7 to be the GCF for what? The 3 numbers. Okay, so what is the GCF for the entire 3 terms?
7.
7 times by what? This is the GCF for the numbers. And for r square, r to the 1st power, r to the 5th, what is the greatest common factor among the 3 exponential expression? I would say r square.
There's 2 in each,
Yes. We cannot choose r to the 5th, right? Because r to the 5th is only a factor of itself, but r to the 5th cannot be a factor of r to the 4 and r to the square, right? So when we are finding the GCF for the variables, we should choose what? The least exponent. Does it make sense, Daniel and then Jose? That makes sense, right? R square is a factor for all of these 3 r's something, right? But r to the 5th cannot be. Okay, so GCF is 7 times r square. You ready to do another question? Let's try number H. Oh, for these 3 terms, we have constant, we have variable x, we have variable y. So first, let's find the GCF for the numbers. 16, 36, and 4. So factor them in terms of the prime numbers, 2 by what? 8, 2 by 4, 2 by 2. So 2 times 2 times 2 times 2 equals 16. Right? And how about 36? 2 by what? 18. 2 by what? 9. 3 by 3. And then number 4 can be factored by what?
2 times 2.
2 times 2. Alright, so what will be the least? Yeah, this is the greatest common factor. So 2, do you have a common 2? Yes, there's a common 2, right? How about, do you have a second number 2?
Right.
Yes. Do you have anything else? No. Okay. So GCF for the number is what? 2 times 2 is 4. And then we're going to multiply by the x term and the y term, or y exponents, right? For x, we have x squared in this term, we have x to the 1st power in this term, we have x to the 1st power in this term. So square, 1st power. For x, we should choose 1. Right? For y, we have 1, we have 2, we have 1, we should choose what? 1. You guys, that was good?
I got a question for G.
G? Number G, right?
Yeah. Because since there's like 2x and then an x and then 18.
What is
1.
1? So, 2, 18, and 1. What is the greatest common factor for these 3 numbers?
1.
Just 1. Right? So the GCF is 1 times by, we have x squared, we have x cubed, we have x. We should times by x to the what?
To the 1st power.
1st power. So GCF is just x.
So we don't need to break it down at all?
How can we factor 1 into a product of prime numbers? 1 is 1. Yeah. So the greatest common factor is 1. Because, right?
I just got confused because with the 18 you could break that down to 2, right?
Yes, you can.
3.
Yeah. Yes, we can factor 2 to be 1 times 2, right? And then 18 can be 2 times by 3 times by 3. However, there's 1. This is 1, right? So,
Okay.
yeah. Alright, so this is a GCF for a list of terms with variables, okay, variable terms. So that's good. First, we should do what? Find the GCF from the numbers. Secondly, we should do what? For each of the variables, okay, each of the variables, find the least what? Keep the least exponent. Now let's try number I. Let's try question number I. 32, 64, and 8. What do you think is the GCF of the three numbers?
Probably 4
4
or 2.
or 2? Is number 8 a factor of 32?
Yes.
Yes. Is number 8 a factor of 64? Yes. So,
So it's 8?
8. Yeah, the GCF is 8. Of course, you can factor out all of the three numbers in terms of the product of prime number. That's fine, okay? However, we can tell 8 is a GCF for numbers. And now let's check. For variable z, these two terms have variable z, right? Does this one has variable z?
No.
So can we write down a z to an exponent? No. The z term has to show, the z variable must show for all of the terms, then it shows up in the GCF. So we cannot put z, just 8. Because this term has a variable y, but this two term does not have variable y, so we don't put a y into our GCF. So eventually GCF is just number 8, that's it. Alright, I will give you time, okay, later in class to finish the rest of the questions, okay, on this page. Now let's move on to look at the question 3. Okay. Write these expressions in factored form by factoring out the GCF. Factor out the GCF, okay, so let's try some easy questions, okay. 3x squared plus 6x. Factor out the GCF from these two terms. What is a GCF?
Greatest
There's
common
3.
Just 3.
And
X squared x.
X.
Yes. So GCF is 3x. And then, guys, we're going to factor out the 3x, which is our GCF, and then see what will be left in our parentheses. Okay. So, if we factor 3x squared by 3 times x, and times by what? 3x times what equals 3x squared?
X plus 2?
X times 3x equals 3x squared, right?
Yes.
And then factor out 6x by 3x. It has to be what?
Plus 2.
3x times 2 equals 6x, right? So now we can check. Oh, 3x times x, 3x squared. 3x times 2 is 6x, right? Another way, if you do know how to figure these terms, what should we do? We use the original terms divided by the 3x. Say, what is 3x squared divided by 3x? X. What is 6x divided by 3x?
2.
Positive 2. So x plus 2, either way. Or if you say, oh, 3x times by what equals 3x what? You know that's x. Oh, 3x times what equals 6x? That's 2. So either way, okay? Alright, so this is question A. Okay, you can try question B. Now let's try question B. 15x times y minus 18 times y times z minus 27x times z. What is the GCF? 15 negative
18. I'm on a different one.
Yeah, so let's factor that if we can now tell, okay? 15, 18, 27. 3, 5, 3, 6. Well, this is 2 times 3, right? 3 times 9, 3 times 3.
3.
So at least we have a common factor 3, right? We don't have a 5. Do we have a 2 for an extra 2 for no? Right? doing an extra 3 for all of these 3? No. So what is the GCF for numbers? Just 3, okay, 3. And for variable x,
They have an X in all of them.
they don't have an x all of them, so we cannot put x.
Oh, that's not a,
Yeah, see, this one doesn't have x. Can we put a y? No. Can we put z?
No.
No, GCF is just 3, right?
Yep.
So to factor, let me write it here, okay? To factor this expression out by a GCF 3, we factor 3 out. What should we have? There are 3 terms. Inside of the parentheses, we should have 3 terms as well. So 3 times what equals 15xy?
5
5 times xy, right?
minus
Minus,
6.
yeah, negative 18 divided by 3 gives us negative 6, right? Y times z. Negative 27 divided by 3, negative 9 times xz.
This is easy.
so, okay. I get it.
We just need time to digest and
Right.
practice more, okay? Alright, so let's try one more problem. Let's try question F, please. Question F. $15, $25, $20. Yeah, find the GCF at first.
The GCF is 5.
GCF is just a 5. I mean, 5 is, yeah, is 5 is GCF for the numbers, right? 3 numbers. And then for x and y, can we put an x in our GCF?
Yes.
X squared, x and x, right? So we should put just x, right? Y squared, y, we put what? Y. So GCF is 5 times x times y. You guys get this step? Now, when you factor out 5 times x times y, and then there will be 3 terms inside of the parentheses. What term times by 5xy will equals 15x squared y? 3x. You agree with 3x?
Yeah, because
Yeah.
3X.
And minus 5y.
Yeah, minus 5 what? Y.
Plus 4.
And then 5xy times what equals 20xy?
Plus 4.
Plus 4. Or if you don't know how to do it, just use each term, divide by the 5xy. We will be able to get these 3 terms inside of the parentheses. That makes sense, right? Because dividing this gives us that. Because reversely, if we distribute this term, GCF to each term, we'll get an original term, right? Okay, so this is the factor out of the GCF. Now, let's look at the factor by grouping. Eventually, okay, I'm going to ask a volunteer to read this box for us, and Jose, it's your turn.
Okay. Factor out the GCF. What are the terms for the first 2 terms have an individual GCF, and the second term has a individual GCF. Factor the individual GCFs from each grouping. Note, the parentheses must match at this point. If they do not, go back to number 1 and try again. Factor out common binomial factor. Check your answer by distributing.
Okay, very good. Thank you so much. I'm going to show you, okay, how to do grouping question. First, this is very important. This is a key step. This is a very important step for all of the factoring question, not just for this section. For all of the rest of the sections, okay, when we're factoring, first factor out the GCF. And then by grouping means, in this polynomial, we're having how many terms?
4.
4 terms, okay? Most of the questions by grouping, we have 4 terms, okay? So among the 4 terms, what do? We group these 4 terms by a pair of what? 2 terms. 2 terms, 2 terms. That's called a grouping, okay? Grouping. And from each pairs of the terms, we grouped, right? Each subgroup, okay? Yeah, each group, we factor out their own individual GCF. And then, what? Must match everything if yeah. So, if we factor out these 2 groups respectively, then we'll find a new GCF. Then we factor the new GCF, we're done. Okay, let me show you how to do this type of problem, okay? I'm going to show you how to do question E. Factor this polynomial by grouping. First, find out the GCF, factor out the GCF. Do we have any GCF? What is the GCF? Numbers. GCF is a common factor. Yes, we can take 6, you're right. GCF is a common factor for every single term. So GCF is what? 6 times by x to the 4th power, x to the cube, x squared, and x. Yes, you're right. Very good. So GCF is 6x. So we're going to factor out 6x. And the first term,
x3.
x to the 3rd. 24x cubed divided by 6x. 4x squared.
Yep.
Negative 12x squared divided by 6x.
Negative 2x.
Yes. Negative 48x divided by 6x. Negative 4. Right? Alright, so we have 4 terms. How can we factor 4 terms? What do? We group them by 2 terms. Every 2 term is a group. And then we're going to factor out whether there are any GCF from these 2 terms, whether there is any factor of GCF from these 2 terms, okay? So 6x times by x to the cube plus 4x squared, any GCF from these 2 terms?
X.
X squared, right? So we can get, if we factor x squared from these 2 terms, we should get what? And x plus 4. You agree with me? Right? Alright. Now, any common factor from these 2 terms?
No.
We have a negative 2, we can say 2, right? We're negative 2, right? We're negative 2. Did we do something wrong here? Are you sure this is the minus 4?
Yeah, I was thinking that. I was like, I can't see.
This is 8.
Yeah.
Because 6 times negative 8 gives us negative 48, right? So why I wrote down a negative 4? You should let me know, okay, if you find anything which is wrong. I make mistakes sometimes. You correct me, okay? Alright, so we have negative 2x and negative 8. Any common factor from this 2 terms? I was like, oh, we're not able to. 2. Or I would say negative 2. Why? Because both of the 2 terms have a negative sign. So let's factor out the negative sign out. So negative 2 x. Negative 8 divided by negative 2.
4.
Yay! See?
This is longer, but...
See? Do you see? Are we able to keep on factoring this term and this term?
If we wanted to,
Yes.
yes.
What is a common factor? What is a
X.
x plus 4? Right? So we're going to... Okay, so 6x plus 6x. Factor out the x plus 4. So from this term, we should have what? X squared. From this term, if x plus 4 is out, we should have a negative 2 left. Right? You see? this result is written by a product of factors. We're done. This is by grouping. If we summarize by grouping, what is a summarize? First, factor out the GCF. Then we have 4 terms. Group the 4 terms into 2 terms and 2 terms. From each of the 2 terms, find out factor out their individual GCF, and then see whether there are new GCF shows up. If so, we keep on factoring, right? Okay, let's try one more question. Let's try the question F, please. Try the question F, please. 2x to the cube minus 3x squared y plus 2x squared y minus 3xy squared.
This is 2. Right, no.
What is a GCF?
Yeah.
Well, 2 is a factor for these 2 terms, but 2 is not a factor of 3, right? These 2 terms. So the GCF, the number part is 1,
Yeah.
right? And then how about the variable term? Variable part. Does every term has an x? Yes. What is at least the exponent? 1, right? Does every term has a... No. So, x shows up for every term, but not y, right? So what is GCF? Just the x. Do you see that? Just the x, okay? So, this question, we're factoring x out and see what we can have. 2x cubed divided by x, 2x squared. Negative 3x squared y divided by x,
Negative 3.
x and y, right?
Well, no, yeah, why? Because what I said.
Plus,
2x squared y divided by x, 2xy, right?
yeah.
Plus 2xy. Negative 3xy squared,
Negative 3.
negative 3y squared. Yeah. Oh, in order to factor this polynomial, these 4 terms, so far the only way we know is what? Grouping. So, from these 2 terms, let's see whether we can find any common factor or not. 2x squared minus 3xy, any common factor?
X.
X, yes. So we should have what? 2x minus what?
3y.
It is 3y.
Yes.
3y. From these 2 terms, what is a common, or at least the greatest common factor?
Oh, shoot. 1?
Yeah, 1 is for the number, right? For a variable x, there's no x in this term, but for y, how about y?
Oh, yeah.
Y, out.
Wait. There's an x. Like, are we taking the x from the second term as well?
Well, the thing is, now we're factoring these 2 terms only, right? X only show up from this term, but x does not show up from this term. So only y is a common factor. So if y is out, we should have what inside?
2x minus 3y.
2x minus 3, y squared over y is what? Y. Have you noticed any new come up?
Yeah.
Common factor? 2x minus 3y. So, x times by factor of 2x minus 3y, we have a x plus what? Y. Done.
I don't like this one.